Good afternoon, everyone. I'm Zhu Yulan from the Department of Neurology, the second hospital of Harbin Medical University, China. It is my great honor to be invited by Professor Lila Akamadiwa. Today, I would like to share my lecture concerning about circadian dysfunction in nervous system disease, and especially focus on circadian dysfunction and stroke. As we all know, the circadian system or circadian clock provides an adaptive advantages for organisms ranging from archaea to humans to the 24 hours periodicity in the Earth's rotation, and the growing list of physiological processes controlled by the circadian clock includes metabolism, hormone expression, and cardiac function, all of which exhibits daily oscillations. In humans, dysfunction of the circadian clock induced by shift work, for example, significantly increases the risk of developing metabolic syndromes, cardiovascular diseases, and cancer, and so on, thereby indicating that these circadian clock-controlled processes have key roles in human physiology and pathology. So today I would like to talk about the circadian dysfunction and stroke from the following three aspects. The first one is hierarchical organization of the circadian clock. So concerning talk about the circadian clock. Let's see, we have master pacemaker, which is in the suprachiasmatic nucleus of the hypothalamus, and which generates internal circadian rhythms in gene expression, electrical physiology, and hormone secretion. The direct projection from the retina transfer the information about light and darkness to the SCN, which synchronizes a phase of SCN rhythms with the external environment. And local circadian clock, we have also local circadian clocks, which are found in different brain regions and throughout the body. We call them peripheral oscillators. Electrical and hormonal signals from the SCN synchronize phases of local circadian clock oscillations. And local circadian clock generates rhythm in gene expression, metabolism, and other physiological activities. Synchronization of different organs such as heart, liver, pancreas, adipose tissue, and the gastrointestinal tract would be optimal for integrated function of the whole organism. Recent discovery of intrinsic circadian fluctuations within these and other peripheral tissues further speaks of the ubiquitous natures of circadian system. Overall, the intricate molecular mechanisms that take away in each cell of different tissues have different independent rhythms modulated by the master clock in the brain. So next, let's talk factors influencing the circadian rhythm. As the circadian system is critical for generate metabolic health, is there any factor influencing the circadian rhythm? So the answer is yes. So let's see the figure. It is summarized by Brennard, and in his study showed us that while regular night and day and night cycles with dark quiet night are supposed to be the basis of the biosynchronized circadian rhythm in humans. Normally, we have a regular 24-hour circadian rhythm. Several factors can contribute to the increase in altered sleep-wake cycles, including noise, patient care interactions, and mechanical ventilation, pain, artificial light, fatigue, stress, and so on. And also include other cognitive dysfunctions. These factors likely contribute to the increase the risk of developing severe circadian rhythm disruptions and leads to disease progression. So clinical research on the circadian disruption and the potential benefits of the interventions to maintain normal sleep-wake cycle is important as needed. So numerous recent studies has already provided us evidence that the circadian clock influences the development and the progression of disease in the experiment setting. So here is molecular mechanisms concerning about the disruption of molecular clock and disease development. Non-functional circadian rhythm protein in peripheral organs were linked to very specific disease, such as clock diabetes, cryptochrome hypertension, peripheral heart attacks, etc. Also, some environmental factors, such as night shift work, exposed to artificial light, and exposed to electromagnetic waves, results in the circadian disruption, mostly by alternating melatonin rhythm. So irregular diet may also lead to circadian disruption. These findings indicates that time of day dependent drug therapy or interventions might be imperative. However, most important seems to be restoration of the circadian rhythm to improve function of the circadian rhythm pathways, such as insulin secretion, inflammation, or metabolism. So here, there is a model of disease development. Several environmental and genetic factors can cause disruption of circadian rhythm and increase the disease risk. And several environmental increased disease and several disruption. This disruption could contribute to the multifocal disease, such as metabolic syndromes, progression of critical illness, cardiac vascular or cerebrovascular disease, and so on. So, what is the relationship between circadian dysfunction and stroke? After we talked about, we will think about these questions. Circadian dysfunction can cause many diseases. Concerning about stroke, what is the relationship between the circadian dysfunction and the stroke? So it's the main contents for my lectures today. So many neurological diseases I have mentioned show the fluctuating rhythm of symptoms and responsiveness to therapy, such as neurodegenerative disorders, epilepsy, and cerebrovascular disease. So let's talk about the circadian rhythm dysfunction with stroke. As we all know, stroke is one of the leading cause of death and a major cause of adult disability. So relatively recent studies of survival in hypertensive patients have revealed that the incidence of stroke exceeded that of the coronary events. There are available data from observational studies suggest that cerebrovascular events are not randomly distributed over time, but have a peculiar distribution along the day. That is circadian variation with morning peak of occurrence. Concerned about week, there is a circadian variation with higher frequencies in the last and first days of the week, and even months of the year, circannual or seasonal variation with predilection for the cold months. So, what happened when there were a stroke on site? So let's talk about these questions from the following 5 aspects. Here is a hospital-based study. The results showed that the stroke evident peak of each type of stroke during the morning hour corresponded to interval between 6 to 12 o'clock, and a lower decrease during afternoon, 12 to 18, and evening, 18 to 24 hours, and midnight, 0 to 6 o'clock. all subtype of stroke it includes ischemic stroke, subarachnoid hemorrhage, and hemorrhagic strokes. So this figure illustrates the distribution of all stroke types, the onset time along the daytime concerning the 4-6 hour intervals. It shows an evident peak during the morning hour. So here is the morning hour, 6 to 12 hour. And the lower decrease incidence during the afternoon, as I mentioned from the last slides. So next, let's see the relationship between the onset of stroke and the diurnal changes of the risk factors. So it has been reported that the morning blood pressure surge and the extremes of the disrupted circadian rhythm, rather or extreme deeper patterns, are independent risk factors for stroke in hypertensive patients. The probability of a stroke occurring upon wakening rather than during the rest of the day, broken down by stroke subtype, is 66 for ischemic stroke and 34 for hemorrhagic strokes. Most ischemic stroke occur upon awakening, and they are typically embolic, but between 20 to 40% of ischemic strokes occur during the night, especially at onset of sleep. These strokes are more commonly atherothrombotic and lacunar. As we mentioned above, this is coincidence with the morning surge of blood pressure. In addition, each 10 mercy increase in 24 hours systolic blood pressure accounts for up to 40% increase in the rate of cardiovascular and cerebrovascular events. So sleep is the most important and consistent source of circadian blood pressure variation. Sleep stages are reflected by consistent changes in blood pressure. So next, let's talk about the role of sleep-wake cycle on blood pressure and the circadian rhythm of stroke. So the deepest, from the papers, we can see that the deepest sleep stage, which is 3 or 4 stages of sleep, coincidence the lowest blood pressure levels. The less deeper stages, stage 1 and 2, and REM sleep, corresponding to relatively higher blood pressure level. And all these sleep stages, the blood pressure are lower than wake state blood pressure level. If patient's absence of normal 10 to 20% decline in blood pressure during sleep period appears to carry a higher heart and cerebral risk, since the amount of time during the 24 hours when blood pressure is elevated, the negative impact, we should say negative impact for the target tissues and the organs is prolonged. So here, we raise the questions. Could the morning peak hypertensive increases the incidence of stroke? The answer is yes. So from this research, we can see the morning surge in blood pressure, both sleep through morning surge and pre-awakening morning surge, defined by ambulatory blood pressure monitoring data, were significantly associated with magnetic resonance image detected silent cerebral infarct and further clinical stroke events, which independently of the subject's 24-hour systolic blood pressure and nocturnal blood pressure deeper status. So here we can see the morning surge group has a higher incidence of silent cerebral infarct and clinical stroke events. And also, we can see that from here, next, blood PAI1 the levels of PAI1 varies rhythmically, which has a peak at approximately 6:30 in humans. This peak time coincides with the peak incidence of myocardial infarction and cerebrovascular disease. Here we can see from the picture. And besides the role of early morning surge of blood pressure, some other pathophysiological factors that may also explain the diurnal pattern of stroke onset include increased platelet aggregation and prothrombotic factors, as well as blunting of endothelial functions in the morning hours. And the peak level of circadian sympathetic activities also occurs in the morning, which along with the simultaneous increased activity of renal angiotensin aldosterone activity. For instance, the morning increase in blood pressure surge and heart rate. Further, the propensity for rapid eye movement sleep increased the early morning hours. This stage of sleep is associated with reduced coronary blood flow and increased coronary spasm, which contributes to the heightened sympathetic activity and increases the blood pressure and heart rate. Primary sleep disorders such as sleep disorder breathing are additional causes through repetitive intermittent overnight hypoxia and sympathetic activities. So all these factors, pathophysiology factors, may also influence the stroke occurrence. So above we have talked about the endogenous factors that affect stroke onset. And then let's turn to the endogenous factors that affect stroke. Stroke is associated with a number of body lifestyle habits, such as smoking, too much alcohol intake, and too little exercise. Also, some specific type of work, such as night shift work, like doctors, nurses, seafaring, and space soldiers or workers. They are always facing with long-term coronary biology disorders. Each of them is also an endogenous factors that induces stroke. So here is some results from the clinical research from Brown, DJ. So here the table shows the hazard ratio of the ischemic stroke by years of working rotating night shift. So it showed that there was an overall association between years of rotating night shift work and stroke adjusted for age and the questionnaire follow-up cycle. It's just that women who worked longer durations for shift work, such as longer than 50 years, had the elevated risk of ischemic stroke compared with the women who never worked by rotating shift work. Well, it is also reported that circadian rhythm could affect the severity of stroke. So next, let's talk about severity of stroke with the circadian rhythm. Here is a classical animal model experiment reported by David J. From the paper and from the picture, we can see, based on the TTC staining in coronary sections obtained 5 days after ET1 induced MCAO, middle cerebral arterial occlusion. Also, while was female in both light-dark paradigms exhibits evidence of cortical or striatal infection. However, females exposed to shift work, shift light and dark, not shift work. It's a female animal. Exposed to shift light dark cycles had significantly larger infarct volumes compared to the fixed light dark controls. So this study demonstrates that circadian dysfunction affects the severity of stroke. So next, the fourth aspect, I would like to talk something about circadian rhythm changes after stroke. We have known that circadian rhythm affects stroke onset, so stroke severity. So let's talk about the rhythm changes after stroke. That means after stroke, the stroke can also cause circadian rhythm dysfunction. To being associated with changes in circadian rhythm, strokes can also alter the circadian rhythm themselves. These papers show has demonstrated these questions. Abnormal circadian rhythm after stroke is very common, and it's associated with poor prognosis. The examples include the infant that affect the secretion of growth hormone and melatonin. The latter may change autonomic circadian variations and contribute to an increase in post-impact mortality. And Ferrer A reported that only 1/3 of patients maintain normal circadian rhythm after stroke, and 20% have subdiurnal or supradiurnal rhythms. 40% have a rectal temperature rhythm that is inconsistent with body movement rhythm. That means the circadian dysfunctions has happened. So here we list 4 types of sleep disorders after stroke, which are insomnia, hypersomnia, sleep disorder, breathing, excessive daytime sleep, and also we can have all other sleep disorders after stroke, such as restless leg syndrome, etc. It has been reported that involuntary stroke have been linked to decreases in non-REM and non-REM sleep, and different parts of the brain infection will also show different sleep patterns. So this is closely related to anatomy, and and this is anatomic basis sleep awakening dysfunction after stroke. For example, stroke in the quantum encephalic junction and the reductors may diminish the amount of non-REM sleep while not affecting the amount of REM sleep. While sleep in the paramedium thalamus and the lower pulse have been linked to lack of sleep wave sleep with preserved REM sleep and to onset of sleep at the beginning of the sleep cycle. And here we list other different stroke locations that produce different types of sleep disorders. We have no time to talk them one by one. And so from all above contents, we will think about questions. How can we avoid the influence of circadian rhythm dysfunction on stroke? So now we can see people are more interested on the time biological strategies for stroke treatment and prevention, concerning about the circadian, the relationship between the circadian rhythm and the stroke. So think about the time biological strategies for stroke prevention. We should think about controlling circadian rhythm disorders, because control circadian rhythm dysfunction can be the target of stroke prevention. We can focus on to change the body habits, such as sleep deprivation, alcohol, coffee, strong tea intake, and to treat sleep disorders, treat insomnia, obstructive sleep apnea, restless leg shift work, restless leg syndromes, and shift work, etc. And to think about to improve the effective treatment of mental and physiological factors and physical diseases. And also, we can think about chronotherapy. Chronotherapy requires special attention when treating stroke patients, which maybe include the time we need to consider about time of drug administration, which is often matters. It is bound to affect the efficacy and side effect of many medications. And also, for some moleculars, we have clear indications that the most favorable time of admission is either the morning or evening, which can exert the best effective of the drug, the efficacy, and to avoid the side effect. And also, we need to consider accurate adhering to pharmacological schedules. That is the crucial point for the clinical success of the therapy. So, I would like to summarize the above contents. Numerous studies have shown the importance of healthy circadian rhythmicity in maintaining neurological homeostasis. Further research on the chronobiology of the neurological disease will be involve greater understanding of the role that circadian phenomena play at the cellular and molecular levels in the pathogenesis and brain disorders. This understanding will form the foundation for the development of new circadian-based interventions to improve clinical management of brain disorders. For example, with increasing understanding of the importance of circadian rhythmicity for brain health. One important direction will be to focus on the importance of chronopharmacology in neurological diseases. Already considered in other medical disciplines, time of day needs to be accounted for when considering side effect and also efficacy of pharmacological therapies. For neurological disorders, the circadian system has therefore become a novel diagnostic and therapeutic target for neurological disorders. So next, I would like to share some of our data. We did just some. We did some work, not too many work, which relate. We observed some relationship between onset time of the cerebral infection and circadian rhythm. Our data source is our patients. We collected 185 cases of cerebral infection patients. They admitted to our hospital in the last 3 months with accurate onset time records as the objects of this study. All cases meet the diagnostic criteria for cerebral vascular disease. All were confirmed by head CT and brain CT and or MRI. Among them, 122 cases were male and 61 were female, ranging from 29 to 83 years old, with an average age of 59.03 years old. Among them, 118 cases, which presents 63 to 0.79%, were in the group of 50 to 59 years old and 60 to 69 years old. This is our results. The stroke onset time, which is the time distribution of onset, at least in this table. Our studies show that the statistical results show there were 119 cases, which is 64.33% in the 2P periods of 4 to 8 and 8 to 12. This result is coincident with the observation of most scholars at home and abroad. Namely, the incidence peak is around the morning and in the morning. The second part of our data is we observed the relationship between early neurological deterioration and circadian rhythm of blood pressure in patients with ischemic stroke. Neurological deterioration in patients with ischemic stroke during treatment is common in clinical work, among which early neurological deterioration abbreviation is END, refers to neurological deterioration occurring within 48 or 72 hours after onset, accounts for 26 to 43% of ischemic stroke patients. Most patients have poor recovery at the END after years, so early intervention for neurological deterioration is of great clinical significance for improve the prognosis of patients. Our data information, let's talk about general information of our data. A total of 103 patients with ischemic stroke who had their first onset and were hospitalized within 24 hours were selected as subjects aged from 50 to 82 years old. The selected subjects meet the diagnostic criteria for cerebrovascular diseases, and all cases were confirmed by brain CT and MR scanning. Here is the exclusion criteria. And the ambulatory blood pressure monitoring was performed in all patients with ischemic stroke initially admitted. And we have time interval. The measurement during the daytime, it's 7 to 20 hours. And every 30 minutes, we measure them. At nighttime, the measurement is every 60 minutes from 20 o'clock to 6:59. Continuous monitoring for 72 hours. And also from the detection, we classify the blood pressure type as the following 4 aspects: super deeper type, deeper type, non-deeper type, and the exceeding deeper type. It's happened. Here is our results. So here we see in different types, we can see the number of the patients belongs to different types. And the result shows that reverse deeper type, non-deeper type, and super deeper type blood pressure are associated with neurological deterioration after stroke, especially the reverse deeper type blood pressure, which may result in mechanical damage of vascular wall due to persistently high night blood pressure, promote platelet aggregation, and increase blood viscosity, leading to the deterioration of the neurological function in the early stage of ischemic stroke. Therefore, it is suggested that in the clinical treatment of ischemic stroke, the control of blood pressure can directly affect the outcome and the prognosis. And it is also necessary to monitor the circadian rhythm of blood pressure to assist clinical rational and effective drug use and actively improve the recovery of patients. So that's our data, our results. Thank you for your attention.